Okay, hello there, everyone. Today I have the big honor to hello there. Today I have the big honor to have Stephen joined me into this conversation. He's an engineer from SILVALOG, and he has. We're going to do a small deep dive into the log deck system. And Stephen, maybe you can introduce yourself, what we have done here, and also what's your profession?
Sure. Thank you, Anders. And hello, everyone. As Anders has mentioned, we'll be looking at the log deck system. As an engineer and compliance expert, I have taken the role to determine the strength capability of the log deck system developed by SILVALOG. And we've looked into the requirements not only by theoretical analysis, but we've also simulated the design into the 3D model and identified the structural integrity of the log deck. And we've also determined the capability both of the deck side and the conveyor going onto the machine.
All right. And what's the reason? Why have you looked into calculations and 3D modeling and doing all this effort?
Indeed, so this is all part of the responsibility that SILVALOG has considered being the manufacturer of such a machine in order to make sure that the machine is safe and according to its intended purpose on the European market. So it is part of the requirements that are required to compile the technical file, and part of which is determining the suitability of the design. It is not by chance that SILVALOG has ensured that the deck is safe in order to determine the correct working load of the deck and the conveyor.
All right. And how has this calculations been done? So I would assume there has been a computer evaluating all different types of weights, and then you'll reduce the maximum weight into a safe margin, or how have you done this?
Correct. So as we're seeing in the image, Anders, we've considered several worst case scenarios on the log deck in order to ensure that the log deck is safe. So we've considered logs of up to 5 meters, and we determined the greatest weight that such logs can be on top of the deck and the conveyor part. We've used, as you've mentioned, finite element analysis via computer software in order to simulate the placement of the logs on the deck.
So you have, when you've done these calculations, is it always the worst case scenarios that you are calculating with, or what's the idea behind it?
Yes, exactly, Anders. So we've considered different worst case scenarios. We've considered a worst case scenario with just the logs on the deck, but we also have to consider the possible abuse on the system, meaning that once the log is placed on the deck, you never know who's going to make use of the log deck. Lowering down the logs on the deck is determined by the user and the capability of the driver who is lowering the logs on the deck, either by forklift or by crane. And it is not always a uniform load and force, considering the action of lowering the log on the deck. So we've considered several dynamic analysis, having the log being lowered down with gentle motion and more aggressive motion on the deck itself. This means that the deck has been through several calculations, as we're seeing on the screen, identifying stresses on the deck beams that are a result of forces being transmitted from the logs down to the decks and the legs.
All right, so you have calculated the maximum capacity of this log deck, and dependent on different types of users that will load into the deck, you have also set a safe maximum, what should I say, a maximum
Load. Correct.
That will be suitable for different types of users, and that load will be on a safe margin when this has been calculated, the maximum capacity for the
Correct.
log loader.
Exactly.
Sorry, log deck.
As you're mentioning, we've considered several scenarios, and the worst case scenario would be when a user is reluctant to consider the suitable use of the machine. So when a user lowers the log without considering the safety of the machine, we've considered that that is the worst case scenario on the machine. Nevertheless, there are additional portions of the machine to identify, and we have considered that there are several aspects that needed to be taken into account. So the deck itself, the conveyor, the size of the logs on both the deck and the conveyor, such that we reached to the minimum allowable safe working load on the whole system. So going through the different scenarios and analysis, we've determined that the total capacity of the deck is capable of handling 2,250 kilograms. That means that 2,250 kilograms can be evenly distributed between the conveyor and the deck itself. That means that the whole system can withstand around 5 logs, each weighing 750 kilograms. And we know from analyzing actual log profiles that this is much more than anyone would use this deck for. Nevertheless, it has been engineered in order to make sure that it is suitable for use in any environment that the deck can be exposed to. And more than anything, it can be used season after season, repeatedly, considering that it is suitable for such high loads.
All right, so it's calculated the worst case scenario here, more or less, for very big logs, 750 kilo each.
Yes.
Loaded into it. And I would agree that's quite big logs.
Indeed. So in summary, we've considered that although this structure is much more capable of withstanding this total of 2,250 kilograms, we've conservatively reduced the maximum allowable weight down to this figure in order to be confident that even if the machine is used carelessly, it can be used time and time again. Nevertheless, the machine has been considered safe, both from a structural aspect and from other criteria that compile the safety of the machine itself.
All right. That sounds really good there, Stephen. And it's also considered a lot of cycles also then, I would assume. So it's calculated over a long period of time, right?
Indeed. So this is not for just one cycle or a couple of cycles, but considering at least 10,000 cycles. So consider that the amount of cycles with this total load exceeds at least 10,000 times. So we are confident that at least for 10,000 instances, it is capable of handling its full load capacity. Considering that the user will place the logs on the deck, transfer the logs down to the conveyor, and the in-feed conveyor will feed towards the wood processor. So throughout this whole cycle, we've considered that it is suitable without any structural deformity to be capable of being used for at least 10,000 times with 2,250 kilograms throughout the machine.
Thank you so much, Stephen, for taking your time to have this online meeting with me and explaining the method behind the calculations and also why it's been manufactured and designed as it is. And it's been designed to handle these types of weights over a long period of time, right?
Indeed. You're welcome, Anders.
Thank you so much. Have a nice day.
Take care.